Hi people, this is Divya. In this video, I'll be showing you how you can download datasets from TDC. Okay, TDC is nothing but this abbreviates to Therapeutic Data Commons. This Therapeutic Data Commons is an open source initiative to help AI ML people, to deal with the chemical compounds. It all beyond data sets, it also has data functions which help us in many ways tackling the data. Let me show you first the data sets and then we'll move on to data functions. Okay, after giving you a brief on what TDC is and how you should actually explore TDC, why you should, and then we'll move on to downloading our dataset. Okay, let me give you an overview of the datasets. We can have datasets of chemical compounds and different datasets. Okay, on TDC, let me show you example. For example, we have toxicity check. Toxicity check is nothing but checking whether a particular compound can can include toxicity in if that particular chemical compound is added to the medicine. For example, let us check Hog blockers. I'm not sure if I'm pronouncing it correct. I call it Hog blockers. Let me show you the um, what it does in detail. Herb blockers is a data set which shows whether a particular whether a particular chemical compound blocks your heart potassium channel, Hog channel. Okay, if the basic criteria is if this particular compound is greater than 10 micro m, then it'll block your heart potassium channel, otherwise it don't. Okay, let me show you the data. uh, yeah, this data needs no cleaning or anything because it is ready to fit in a model like random forest classifier, any model which you want to use and train it with. So this is very useful because it you know removes all of the pre training activities, so very time saving. And this is an open source voluntary work done by people, so it is very good to see that, right? Okay, let me explain you about the data set. It has three columns. In the first column has the name of the chemical compound, and the second one has the chemical formula, and then the third one is the output. If the y, that is output, is 1, that indicates that this particular chemical compound blocks our her potassium channel if it is included in the medicine, or in general this can block our heart's hurt potassium channel. If the particular Y is 0, then that particular compound doesn't. Basically, explaining us the toxicity of that particular chemical compound. Okay, and there are many data sets you can go through and explore. So these all data sets are cleaned and ready to work on. Yeah, coming to the data functions, this TDC website has many useful functions. For example, let's say model evaluation. Model evaluation needs, we need mean squared error or many functions, right? We use many different things to evaluate our model, say precision, ROC, AUC curve, many things we use to evaluate our model. So, this is very handy. For example, let's say precision. Precision is, the easier one. Okay. It just gives you the everything you need. Description says the precision calculates the fraction of correctly predicted positive instance out of the total predicted positive values at a threshold. Correct. And this is the function. You can use this function and calculate precision and evaluate your model. So very handy, right? And then coming to the data splits, you can we all split our data into train, valid, and test data, or sometimes train and test based on the model and the data needs. Here are different types of methods via which we can split our data, that is random split. When you use split function, it is like you don't need to mention method equals to random, because by default it is considered random split. And then you can split the data, either randomly in a specific ratio, that is usually I follow 70-20-10. 70% of the data to train the model, 20% of the data to test the model, and 10% to validate the model. So if you just randomly split, our model just randomly splits a particular amount, particular compounds into test, train, and valid. But you can also split them using this method, scaffold split. What does this do? This splits based on the scaffold. Scaffold is nothing but the internal core structure of the molecules, right? Let me just read it for you. Scaffold split is based on the scaffold of the molecules, that is internal structure of the molecules. So that train, valid, and test set is more structurally different. Correct. Do you get the point? They should be more structurally different in order to test the generosity of our model. Because if a new compound, if we test our model on a new compound, it shouldn't like more there is no particular confirmation that the new compound is anywhere similar to our training data. So definitely there are different types of splits you can use to split your data. So if you're working with chemical compounds, biomedical, biochemical, machine learning, I would definitely recommend you to explore this TDC website. Okay, now coming